Hello, I'm Basalis and represent AnyplaceCV, an infrastructure-less localization in Anyplace with computer vision. There is a need for high-accuracy infrastructure-less localization. There are harsh environments like complex industrial environments, underground mines, and vessels where you cannot have any infrastructure. Alternative approaches like magnetic localization do not have high accuracy, and they require stationary steel structure. And in the case of vessels, they're not applicable because a vessel is a huge steel structure that it moves. Other approaches like the IMU sensors that you can find on a mobile phone are also not applicable as they suffer from drifting. And that drift error increases as the time goes by. They require a signal to correct them every once in a while. So how do we solve this? How about using computer vision in order to get a high level understanding of our surroundings, and then based on those surroundings or those objects that we can see, figure out what our location is. So our solution has 4 steps. First, we generate a dataset, and then we use it to generate a deep learning model. And then we use that model to create a localization database. And finally, using that database, we can provide localization and tracking that uses just the camera, no other infrastructure. Let's see how we do our training. First, our users supply some videos, which we annotate using the CVAT tool. Then we train the deep learning model, and we use a YOLO and the darknet neural network. Finally, we convert it to TensorFlow Lite, which is fast and lightweight and can run well on mobile phones. Our applications can use between 3 different models. The first is named Lashko, that has around 100 classes, and it recognizes objects that can be found on vessels. Use YCO is recognizing objects that can be found on a university campus, and COCO is a publicly available dataset that recognizes commonly available objects. Now let's see logging and localization. To create a fingerprint database, we can utilize the AnyplaceCV logger. It allows us to associate spatial coordinates with recognized objects. The process is quite easy. The users select a deep learning model, then they select the location of the map, then the camera will fire up, some objects will be recognized, a location will be assigned to those objects, and then this process will repeat. Once this is done enough times, we can create a fingerprint database. At the end, we visualize the density of the fingerprint so the users will know which areas might need improvement. In special cases where the fingerprint needs improvement, we can utilize QR codes to improve accuracy. Now let's see the localization and tracking in action. The users can acquire their physical location based on their surroundings. There is no need for infrastructure. They just need their smartphone camera. We use this technology to build a location-aware smart alert system for Lashfire. We allow users to track other users, and we also allow them to send some alerts. We also allow nearby communication. In this example, a user is sending a message to each other user. We can limit the reachability of a message to the same deck, to the K nearest neighbor, or to a bounding box. In this example, we are attaching a thermal image. We can also attach the user's CV-derived location. So this was AnyplaceCV, an infrastructure-less localization in any place with computer vision. Thank you.